Welcome, everyone, to this explainer. I am absolutely thrilled to have you here today. For the next few minutes, I want you to think of me as your senior developer mentor. We are going to dive into a concept that literally separates the amateurs from the true professionals in Python programming, and that is encapsulation. Look, if you've been writing Python for a while, you probably know how to make your code work, right? But today, we're going to talk about how to make that code safe, clean, and totally up to industry standards. So let's dive right into this and level up those coding skills.
You know, there is this unwritten rule among senior developers. It goes something like this: better not to touch this outside of the class. These are manners. These are ethics. Now, in Python, unlike some other languages out there, the language itself doesn't strictly lock you out of modifying private data if you try really, really hard. It's flexible. But here's the thing. Just because you can hack into a variable directly definitely doesn't mean you should. Directly modifying private variables from outside a class is considered incredibly amateurish. Following the unwritten rules of data access, well, that's really all about professional etiquette and coding ethics.
Okay, so here's our roadmap for today. First, we'll cover coding to industry standards. Then we'll look at the medicine capsule analogy, followed by hiding your private data. After that, we'll get into professional getters and setters, data validation and setters, and we'll wrap the whole thing up with security and code modularity. Let's kick things off with Section 1, coding to industry standards. When you start working in large teams or maybe on huge enterprise-level applications, you realize very quickly that code isn't just about making the computer do a specific task. It's really about protecting the integrity of your application. Encapsulation is actually one of the 4 absolute core pillars of object-oriented programming, standing right up there alongside inheritance, abstraction, and polymorphism. It is a completely non-negotiable standard for secure programming. So what is it exactly? Well, encapsulation is simply wrapping up data and the methods that act upon that data into a single, neat unit. Think of this fundamentally as a protective shield. In programming, your data is often super sensitive or it's absolutely crucial to the state of your application. You definitely do not want the outside world, and by that I mean other random parts of your program, just reaching in and changing things whenever they feel like it. Encapsulation bundles your data and your approved methods together, shielding everything from unauthorized access.
Moving right along to Section 2, the medicine capsule analogy.
Abstract computer science theory is always a whole lot easier to grasp when we make it tangible, right? So think about when you're sick. You take a medicine capsule. Inside that capsule are various chemicals and drugs, carefully measured and bundled together safely. You don't break the capsule open and just eat the individual powders, do you? No way. You swallow the capsule as one complete, safely wrapped unit, and it does its job inside your body. Well, a Python class works the exact same way. The attributes, which are your data, and the methods, which are your functions, are bundled together into one safe unit. You interact with the class as a whole, rather than picking apart its individual sensitive components. Next up, Section 3, hiding your private data. When you're out there working on real-world industry projects, you're inevitably going to handle sensitive information. Stuff like a user's age, a bank balance, or a specific system configuration. So how do we actually lock that capsule? The syntax in Python is incredibly simple but highly effective. It's the double underscore. By prefixing an attribute with double underscores like __age, you are explicitly declaring it as a private instance variable. If someone working on a totally different part of the code base tries to print or access that age variable directly from outside the class, Python will instantly throw an attribute error, basically telling them, hey, this object has no such attribute. It effectively hides the data from direct public access. But because Python loves flexibility, developers inevitably found a little loophole called name mangling. Someone could technically type object._classname__age to bypass the restriction and modify the data anyway. But listen to me closely on this. Using name mangling as a hack to modify private data directly is a terrible amateur habit. It's exactly the kind of shortcut that leads to a frantic 3 a.m. debugging session because someone accidentally overwrote a critical system state. It completely breaks the trust and the architecture of the code. A professional programmer simply never does this in production. You respect the double underscore. All right, let's jump into Section 4, professional getters and setters. Now, you might be wondering, if we aren't allowed to touch private variables directly, and we definitely shouldn't use hacky tricks like name mangling, how in the world are we supposed to interact with our own data? Well, we use 2 distinct, industry-approved tools, getters and setters. The getter is perfectly named, by the way. It's a public method you create inside your class solely to access or return that private data safely. And the setter method is its partner, used to safely modify or update that private data. By routing all your access through these specific methods, you maintain total, absolute control over your class. You are implementing complete encapsulation and maintaining strict coding ethics. This brings us to Section 5, Data Validation in Setters. So why go through all this trouble just to change a simple variable? Because a setter method acts as a strict guardrail against bad, corrupted, or even malicious input. Let's imagine our program requires that a student's age cannot be over 35. Step 1, our setter method receives the input age. Step 2, we check the logic. Is this age greater than 35? Step 3, if it is, we don't just crash the whole program, we reject the bad data gracefully, maybe by printing out a helpful error message. And finally, Step 4, if the data is valid, we apply it safely to our private variable.
The code for this is actually wonderfully straightforward. We just write, if age is greater than 35, we print an error. Else, we update our private age variable. This brilliantly illustrates exactly why we use setters. Without it, a junior developer could accidentally set a user's age to 999 or maybe -50, silently breaking your application's logic much further down the line. By keeping that age variable private and forcing everyone to use the specific setter method, you guarantee that no unauthorized or dangerous modifications can ever happen. Your data remains pure and valid.
And finally, Section 6, Security and Code Modularity. So, zooming out a bit, why does this matter so immensely for large team environments? Look, when you move from writing small scripts on your own laptop to contributing to a massive software product, the game changes completely. Tech leads are looking for quality code that provides enhanced security by preventing accidental tampering. Encapsulation enables complete data hiding, which actually implements the concept of abstraction at the design level, meaning we're hiding complex implementation details from users who just don't need to see them. Plus, it vastly improves overall code readability. When a developer sees a getter or setter, they immediately understand your intent. And finally, it makes projects highly maintainable. Think about it. If you need to change how an age is validated in the future, you only have to update it inside one single setter method, rather than hunting down 100 different places where the variable might have been modified directly. It's a real game changer. So I want to leave you with this question to think about. After learning these industry standards for encapsulation today, is your Python code really ready for professional review? Take a look at some of your recent projects. Are you leaving your sensitive data totally exposed? Are you relying on good intentions instead of strong setters with actual validation logic? I challenge you to go back to your code today, apply these professional ethics, wrap up your data safely, and start coding exactly like the senior developers do. Thank you so much for joining me for this explainer. Keep practicing those skills, and I'll see you in the next one.